This conference will now be recorded.
So glycosides are organic natural compounds obtained from plants or animal sources which are enzymatic or acid hydrolysis give one or more sugar moieties and a non-sugar moiety which is known as a glycon and linked with a glycosidic linkage. So if you want to see the glycosidic linkage, you can see this is a glycosidic linkage. This is a glucose and this is an a glycon OH group of this and OH group of this glycon. This is a glycon OH group and the glycon OH group will get interacted and it will forms an O-glycosidic bond with the loss of one water molecules. That's what I was trying to explain yesterday. This we call it as an glycosidic linkage. So glycosidic linkage is very important to us. So without a glycosidic linkage, sugar and non-sugar or the glycon or aglycon will not get linked. Until unless they are not linked, there is no pharmacological activity. Sugar portion we call it known as a glycon and non-sugar portion as an aglycon. The linkage between the sugar and non-sugar is known as a glycosidic linkage, or sometimes it is oxygen linkage if it is a O linkage, if not it is a glycosidic linkage. So the pharmacological activity of not only the cardiac glycosides, in generally the glycosides depends upon the aglycon and the sugar attachments. You can't say it is only the because of a glycon, it is the based on the sugar also. Medicinal action majorly or pharmacological activity depends on the aglycon, whereas the sugar moiety it's for its pharmacokinetic activity where it enhances the solubility and it reaches the aglycon part to the site of action. Then we have seen about the chemically these are we have yesterday chemically when the chemistry is being asked, you have to tell these are the acetols or the sugar ethers formed by the interaction of hydroxyl molecule of non-sugar and the sugar moiety with the loss of water molecule. The hydroxyl group of aglycon may be alcoholic or the phenolic. In case of aglycon, I'm telling, not the carbohydrate or the glucose. So aglycon may be alcoholic or the phenolic. I've explained what is an alcoholic hydroxyl group or the phenolic hydroxy. Even it is asked the chemistry, you have to write about this. So it is a when it is asked, it is the acetols or the sugar ethers you have to, then you have to write about the one reaction. The previously I have shown that reaction. Then the hydroxyl group of this aglycon, where it shows the pharmacological, the drug which shows the pharmacological activity, that might be of a phenolic or the alcoholic. Then the sugars involved in these glycosides are the usually in generally beta D glucose, but sometimes apart from a beta D glucose, it also contains a galactose, mannose, rhamnose, digitoxose, and the cymarose. So coming to the again the chemistry, stereochemically these are alpha and beta glycosides. They can exist both as an alpha and the beta glycosides, which may be considered as theoretical aspect because the plants contains only the beta glycosides. So linkage between glycon and aglycon is called as a glycosidic linkage, and it has only the, so in stereochemically or in generally in theoretical aspect we say that there are alpha beta glycosides exist, but practical aspect, when you take practically, there are only the beta glycosides. So this is about the chemistry, and when the chemistry is asked, you have to write the classification also. The chemistry, you are writing about the sugars, you are writing about the linkage, you are writing about the sugar ethers, means it is ether or the this one. See, if it is contains a glucose, so before that before this, it's classified based on the chemical nature of a glycon or therapeutical activity exhibited by the same, or by the glycosidic linkage, or by the, there are three types of classification. It is based on the glycon part, based on the glycon part, and based on the linkage, and based on the uses. So classified based on the glycan, classified based on the therapeutic activity of the glycosides, and classified based on the glycan part. Sorry, glycan part, and the uses, and also the linkage. So coming to this, now based on the sugar present, it is known as, like if it is a glucose is present, they are known as a glucosides. If it contains a galactose, they are known as a galactosides. If it contains a mannose, it is known as a mannosides. If it contains a arabinose, arabinosides. If it contains a rhamnose, then it is called as a rhamnosides. If it contains a pentose, then it is called as a pentosides. So usually in general, the sugars involved in the structure or in the formation of glycosides are the common type of sugars. In very few cases, the sugars like digitoxose and cymarose are present. Digitoxose in digitalis and cymarose in a cymarose plant, it is present. If not, usually the general glucose or the sugars are the present. So this is a one classification based on the glycon or the glucose or the sugar component. Next classification is based on the linkage. So classification is by considering the linkage across the glycon and aglycon. Basically, all types of glycosides linkages occurred by interaction of hydroxyl group of glycon and hydrogen coming through the any of the radical like CH, OH, SH and NH present in the aglycon part. So that OH and H, when they get interact, they'll get removed. So here you can hence by elimination of one water molecule linkage or a bridge is formed, and the type of glycoside formed are named by putting a prefix of that linkage, that is O glycosides, S like glycoside, N glycosides and C glycoside. Means OH group of aglycon, SH group of aglycon, NH group of aglycon, CH group of aglycon will get linked with the OH group of a glycon. Any doubts?
No.
Now, O glycosides, these are very common in higher plants. For example, senna, rhubarb, etc. These O glycosides are easily hydrolyzed by the treatment of acids or alkali. So for us, hydrolysis is very important because once they get either with a with either enzyme or with the acid, they undergo hydrolysis. If they undergo hydrolysis, there is no pharmacological activity. Now, if this glycosides, they are easily undergo the hydrolysis by using an acid or the alkali. Next, from O glycosides, you come back to C glycosides, the last one. C glycosides, some anthraquinone glycosides such as senosides, cascarosides, not senosides, cascarosides from cascara, aloin from aloe. These, I think aloes you know, aloin will get. from allose that contains a C glycosides, whereas senna contains a O glycosides. Now, this C glycosides, which is present in cascara, this resists the just the hydrolysis with the acid or the alkali. So this C glycosides, this majorly present in aloin, and these are majorly present in the Liliaceae family. And these C glycosides, which is formed by the glycon of hydroxyl group and a H of aglycon, CH of aglycon, they form a C glycon. C aglycon will be formed with a water molecule. I'll share the notes, you can read that. So here this C glycosides, what we are seeing, this C glycoside, it resists the normal hydrolysis with the alkali or the acid. So we have to do the oxidative hydrolysis with ferric chloride. This is an important point. You don't sit simply. These are the few points. So running points you have to write. C glycosides are formed by the hydroxyl group of glycon and CH group of aglycon. It forms a C linkage. These C glycosides majorly present in anthraquinone glycosides like cascara and allose. The allo contain alloin, which is a C glycoside, majorly present in Liliaceae family. These C glycosides resist the normal hydrolysis. So these has to be hydrolyzed by oxidative hydrolysis by ferric chloride. Later when we go further, I'll explain you what are the tests for these anthraquinone glycosides or the C glycosides. You will understand then what is oxidative hydrolysis. Now you have to know this much. There is a C glycosides, O glycosides. C glycosides resist. What is the difference between O glycoside, C glycoside is asked. Then you have to tell that they resist the normal hydrolysis, but they undergo the oxidative hydrolysis by or with ferric chloride. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. Then coming to the S glycosides. S glycosides, their occurrence is very restricted to isothiocyanate glycosides. What are they? They're isothiocyanate glycosides. So like cinegreen, it is a mustard, no, black mustard. So black mustard contains this cinegreen. This isothiocyanate glycosides are present in that. They are formed between the reaction between the SH group of a glycon and OH group of glycon. Always OH group of a glycon is taken with the SH group of a glycon. So it forms an S aglycon dash S dash glycon plus water. I had written here somewhere, no? Here. So here what happens, if this is an aglycon, this hydroxyl group, now it may not be OH always. If it is an OH, then it forms an OH plus H, it forms a glycoside, O glycoside. Now instead of H, here if it is a CH, then CH, then there is an this much will go off. Yeah, this will go off and it will form as a RC R dash C dash X. And if it is there is no H here, then instead of it is there is no O here, it's an H will be there here. This OH plus H will go off and it will form as an it will from here it will go off. This much will go off. This much will go off. Ayo Shiva. This much will go off, and you will have R dash C dash X. So that will form a RCX, that is C glycoside. Same way, here you will have a SH. Instead of C, it will have an S here, then it is an SHX. Then you will have a bond. When you remove these three moieties, like an H2O, when it is gone, you will have a RSX. X is an aglycon, R is a glycon, and you are linked with the like this R dash S dash X. Now R is your glycon, S is a linkage, and then it is a glycon. So these are called as S glycosides. Same way with the NH also, that is N glycosides. Instead of S, it will be there NH. So here you will have an N linkage where RNX. This is a sugar moiety. This is a non-sugar moiety. These two are linked by a N linkage. They are called as a N glycosides. These are also they are also known as nucleosides, where the amino group of base reacts with the hydroxyl group of ribose or deoxyribose and gives a N-glycoside form. So all these glycosides contain sugars, but still the physical, chemical and therapeutic properties are detected by or dictated by a glycon part. The sugar moiety facilitates the absorption of glycosides and helps in the transportation of glycon portion to the site of action. The glycosides contain sugars, but still all the properties, physical, chemical and therapeutic properties are due to the glycon part. But the sugar moiety facilitates the absorption of glycosides and helps in the transportation of a glycon portion to the site of action. So now one more classification is based on the, now we have completed the classification based on the glycon, then the based on the linkage. One more is classification is before going to the based on the glycon. We have one more classification based on the therapeutic activity, that is uses like cathartics, cardiotonics, analgesics, antirheumatics, anti-ulcer. So this cathartics, you can give an example of rhubarb. Then I think so, not right. Okay. So cardiotonics, you can make it as an digitalis. So like etc. That I'll make a slide and I'll explain once again. So this is based on the therapeutic activity. One more classification is there, that is based on the chemical nature. So you can see here, it contains an cardiac glycoside. It is based on the classification of a glycon. So it contains a cardioactive glycosides or the cardiac glycosides, anthraquinone glycosides, saponin glycosides, cyanophore or cyanogenetic glycosides, isothiocyanate glycosides, lactone glycosides, aldehyde glycosides, I have given as a miscellaneous. Apart from that, it contains a steroidal glycosides, phenol glycosides, and flavonoid glycosides. Three. It comes under a miscellaneous, or else you can write it as such as a steroidal, phenol, and flavonoids. Cardioglycosides, anthraquinone glycosides, cardioglycosides digitalis, anthraquinone allose or senna, saponin glycosides, glyceriza glabra, licorice, cyanogenetic wild cherry bark or bitter almond. Almond is there what we eat. This is a bitter almond which contains the cyanogenetic glycosides. Then isothiocyanate glycosides, which contains a black mustard. Mustard, what we use, no, that contains isothiocyanate glycosides. Next one is lactone glycosides, which contains a cantharite. Then aldehyde glycosides or vanilla pots contains aldehyde. Apart from that, very important is flavonol or flavonoid glycosides. That is, its citrus fruits contains a flavonol. Then phenol glycosides is there, that is bearberry. Then one more we call it as a steroidal glycosides, where a solanum species contains a steroidal glycosides. So there are 10 classifications. Instead of miscellaneous, we will go with the other three, that is flavonol, steroidal, phenol. Cardioglycosides, anthraquinone glycosides, saponin glycosides, cyanopho-glycosides, isothiocyanate glycosides, aldehyde glycosides, steroidal glycosides, phenol glycosides, and flavonol glycosides. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So the glycosides are classified based on the 4, right? What are those? First one is based on the
Glycol.
glycon, aglycon, linkage, and their uses. Uses: cathartics, cardiotonics, analgesic, antidiuretic, anything you can write, but give an example for that. You can write minimum of 4, maximum to your wish. So you just write those 4: cathartics, cardiotonics, analgesics, antirheumatics, or the which expels the gas from the stomach. What are they called? Carminatives. Any of this, you have the uses or the this one that can be written with an example. Linkage, I think you have understood very well. The linkage classification with the glycon and the aglycon. Then come to the glycon based on the type of a sugar present, glucose, rhamnose, pentose. The other one is based on the aglycon. I want you to write a 10 classification. In that, anthraquinone, cardiac glycosides, saponin glycosides are very important. So these you have to write with the cyanogenetic, isothiocyanate, then aldehyde glycosides, phenol, steroidal, and flavonol glycosides. Any doubts?
No, ma'am.
Okay, then see, till here you have to write if they ask the chemistry of glycosides. Okay, chemistry you have to start from a definition to till here. If you write, it is a chemistry of glycosides. Coming to the properties, I have explained in the last class also. Still, again I am telling, glycosides are crystalline or amorphous substances. These are soluble in water and dilute alcohol, and they are insoluble in organic solvents like chloroform and ether. But the aglycon moiety is soluble in non-polar solvents like benzene, aglycon. But glycosides are, but aglycon is easily soluble in non-polar, but glycon is soluble only in water. But as such, glycosides are soluble in, glycosides means when it is linked with the glycon and aglycon, then it is called as a glycoside. That is soluble in water and dilute alcohol. When you say aglycon and the glycon, the solubility differs. Glycosides are easily hydrolyzed by water, mineral acids, and enzymes. Water, mineral acids, and enzymes. They show optical activity normally with the levorotatory effects. Right? We say that there is an alpha beta exists theoretically, but only the beta glycosides exist in the plants. Glycosides does not reduce the failing solution until they are hydrolyzed. This is very important because glycosides are linked together. There is no free sugar present to react with the failing solution. That's what I said. Hydrolysis. When you hydrolyze, failings get separated, sugar gets separated. That sugar you are going to identify by the failings test. If as such you're taking a glycoside and doing a test, you don't get any failings test positive, and you might say there is glycosides are absent. But you have to hydrolyze and see that it's only this failings test or the Mollis test is it's only the confirmatory test for presence of glycosides, but you will never come to know what type of glycosides present in this until unless you do a test for aglycon moiety. There is a specific test for each aglycon what I specified in the based on the classification of aglycon. We have specified 10 classification. So that 10 classification, for each one there is a specific test, not like alkaloids you do a 4 test and you will confirm these are alkaloids, but here you will confirm when you hydrolyze and do the test for sugar failings test, you will tell these are glycosides. That's all. What type of glycosides you cannot tell. So for that you will have each specific test. For anthraquinone, cardiac, saponin will have a specific test. If you do that test, you will know which type of aglycon is present. If not, for to do the aglycon test or the glycon test, it has to be hydrolyzed, means these have to be separated. When you separate, that's why any test you do it in glycosides, we will hydrolyze, we'll add an acid, we'll separate them, then you add a reagents which gives a positive test for that aglycon. If you are doing a failings test, hydrolyze it, then you add the failings reagent. That's why I was stressing too much on the O glycosides and the C glycosides. O glycosides easily get hydrolyzed if you just add the acid. Whereas in case of a C glycosides, it will not get easily hydrolyzed. You have to do the oxidative hydrolysis. When you do oxidate, means you have to add a ferric chloride, then you have to add either HCl or the sulfuric acid, then only the hydrolysis takes place. That's what we call it as an oxidative hydrolysis. Is this clear or should I explain again? Then method of extraction, we follow the Stas-Otto method for extraction. That will take up in the next class. But till now today you have to